All right, good morning. This is take number 3 again. Having some technical difficulties, but anyways, yesterday I would have finished up with a discussion of natural vibration or natural frequency. And just about everything has a natural frequency that it likes to vibrate at. Like a quarter, if you drop a quarter on my table here in my house, it would sound the same as that quarter would sound if it dropped on your table or at the convenience store or whatever, because the material in that quarter is the same now anyways. The quarters are minted all with the same material. So that quarter has the same frequency called a natural frequency that it likes to vibrate at. Okay? When you force something to vibrate at its natural frequency, a frequency that it likes to vibrate at, it will resonate. You saw a perfect example yesterday. If you saw the Tacoma Narrows Bridge video, that bridge resonated. In other words, it vibrated at the frequency that it wanted to vibrate at due to the structure of the bridge and the wind, and etc. Everything was just right. And so it got bigger and bigger and bigger, and the amplitude gets really big when it resonates. Just a quick example, I have two tuning forks that are both the same frequency. This is a 256 and this is a 256. So if I strike this one and bring it near the other one, stop this one, I can hear that. Even though I didn't strike it, this one is vibrating at 256. Okay, pretend. And this one wants to vibrate at 256, so all of a sudden it starts vibrating at 256 also. And so it's a good example of forcing something to vibrate at its natural frequency. And if the amplitude gets, if it's continued, the amplitude can get really big and sometimes break structures like that Tacoma Narrows Bridge. So that's a pretty good example. There are some other examples. There's musical examples. There's a Indian guitar called the sitar. It has two sets of strings, and you play one. The other set of strings is called the sympathetic set of strings. You play one, and it forces the other ones to vibrate because they're in proximity to the first set of strings. I think there's a picture of it in your book, or you could research it, but it's called the sitar. I believe it's S-I-T-A-R. Some of you may be familiar with that instrument, but anyways, similar example of forcing something to vibrate. Just being in proximity, it wants to vibrate at its natural frequency. So you have some work time today, a little video stuff today, perhaps, maybe not. Can't remember what I'm going to do with that, but tomorrow or Monday and Tuesday we're going to do some lab stuff. I went into school yesterday and got some tuning forks and did some data collection, so should be good with that. Yeah, so enjoy your weekend. Not a whole lot of work today, just some reading and some stuff, and easy, like I mentioned yesterday, pretty easy chapter, pretty straightforward, and probably a good one to wrap up the term on. So, okay, hope you're doing well. Miss you guys. See ya.